In this video, I'll go over all of the ray diagrams, but I'll show them briefly. This is just an overview of all the ray diagrams we have. So here's a converging lens, and you have two options for a converging lens. So let's draw one and another one below it. Here's another converging lens. In one case, you have the object outside of the focal point. So here's the focal point. In another case, you have the object inside of the focal point. So this is what you would have. And the rays of light that you would need would look like this. Here's a ray of light. Well, actually, first of all, you would need the second focal point. So you have to add the second focal point on the other side. Here's the second focal point. Here's a second focal point. You have to make sure that they're equidistant to the lens. And so now rays of light. Here's the first one. Yeah, let's use white. So here's the first ray of light. Goes like this, refracts, goes through the focal point, goes out like that. That should do. Here's the second ray of light, goes through this focal point, and then refracts and goes out like that. And the image would be right here. So it may be in blue this time. So the image would be right here, and this would be a real image. For the second one, the ray of light would go off of here towards the lens, then it refracts, goes through the focal point. So there's that. The second one goes as if it was coming from that focal point, so it goes up like this, refracts and goes in a direction that is horizontal. So it goes like this. Let's give it directions. First ray, second ray, and what you do here is you just draw extensions. So here's one extension. Here's the second extension. Whatever they cross is where you would have the image. So the image would be right here. Oh, I was going to use blue. All right. So the image is right here. And this would be a virtual image because it's not formed by actual rays of light. Okay. The diverging lens would, so let's draw a diverging lens here. Here's the central axis. Here's the diverging lens. There's only one way to draw ray diagrams for the diverging lens. It doesn't matter whether the object is inside or outside of the focal point. Let's put the object here. And then the focal point maybe out here. Make sure that, I was using that. Okay. Make sure that the focal point is equidistant on both sides. And then let's draw the ray diagrams. We need two rays, one reflects off of this, it is parallel to central axis, gets here, and it goes out as if it was coming from that focal point. So it goes out like this, that's about right. And this is the direction. Second ray of light goes from, reflects off of the tip of the arrow, goes to the lens as if it was going to this focal point, but it can't make it there, it just stops here. Then refracts and it goes parallel to the central axis. This is the direction, and you extend these. So here's the first extension of the first ray. Here's the second extension of the second ray. And wherever they cross is where you would have the image. So they cross somewhere here. Here's your image, and this is a virtual image. All right, now for the mirrors. So let's do the convex mirror first. So here's the central axis, and then another one central axis. Then we'll do the other mirror. Okay, here's the first mirror, convex, and convex mirror goes like this. Here's another convex mirror, goes like this. And then we'll do the concave mirror, so we'll draw something like this. All right, now the object here is going to be outside of the focal point. Here it is going to be within the focal point. And here's the focal point, and here's the object. Let's draw the ray diagrams. So for the first one on top, here's the first ray. goes like this. Here's this, and points in this direction. Here's the second ray, goes like this, and just comes back out like that. The image would be right here. And this would be a real image. So this is a real image formed by actual rays of light. For the next one, we would have a ray of light that reflects off of the tip, goes here. Oh, that's blue. Let's change this thing out to white. Goes like this, reflects off the mirror, comes back to the focal point in this direction. And the second one will go, it's as if it was coming from the focal point and gets to the lens, I mean to the mirror. So it goes like this, reflects off the mirror and comes back in the direction that is parallel. All right, so this is what we have. And then what we do is we run an extension here. We run an extension here. Whatever they cross is where we have the image. And this would be a virtual image, because it's formed by extensions, not by actual rays of light. And then the last one is, so here's one ray of light, goes here, reflects back as if it was coming from the focal point. And then here's another one, goes like this, going towards the focal point, doesn't make it there, reflects back. And then we run the extensions of these. So here's the first one extended. Here's the second one extended. Whatever these extensions cross is where we have the image. So here's the image. And this would be a virtual image. Virtual image because it's not formed by actual rays of light. All right, so these are all the different diagrams. Now I'm going to give you an equation for all of this. So here's the equation, and it works for all of these images. 1 over the focal point equals 1 over the image distance plus 1 over the object distance. So yes, I'll write this out. F is the focal distance. Focal distance, which is the distance to the focal point from the lens. I is the image distance. Image distance, so it'd be distance from the lens or the mirror to the image. And O is the distance to the object, so object distance. And if I were to draw a brief picture with all of this, I guess I would do this. Here's the object, here's the focal point, here's the focal point, so F and F. And the image, now let's see, the image would be formed somewhere here, so I'm going to put the image right here. All right, so this is O, object distance, where this is the object. This is the I, the image distance. This is the image. And then F is just the focal length. F is the focal length of that. The only thing you have to pay attention to is the signs. Sometimes the signs of these things here, depending on what lens you have or what mirror you have, you may have pluses, positives, or negative. And the signs are in a table on your equation sheet. So watch out for the signs. I'm going to try to copy that table in here so you can see it. Right, so here's your table for the signs. Just copied it off of the equation sheet. So if you have the equation sheet, it's there. And positives, negatives, O is the object distance, I is the image distance, F is the focal length. So you would only get I would only give you problems where you have object on the left hand side and therefore it would always be positive, so you couldn't have it as a negative. Besides, even if that was the case, you could always flip it and still make O always be positive. I is going to be positive for for a converging I is going to be positive where you have a real image, and so I'm going to put here this is where you have real images, and it is going to be negative if you have virtual images. So virtual images, and now virtual images show up in this type of a mirror and in this type of a lens, and real images show up with this mirror and with this lens. So so there's that, and then f is the focal length, and focal length would be positive for converging lenses and for concave mirrors, and negative for diverging lenses and convex mirrors. That's interesting, which means that this is a convex mirror. I always forget, I always mix them up. Anyways, it should be if the rays of light come in and reflect like that, then you would have the focal length being negative. And if your mirror looks like this, then and the rays of light come in from the left and reflect off of it, then you would have a positive focal length. Okay, that's interesting, because I might have done one video where I was speaking about concave mirror, but it was actually convex. Anyways, the picture is there, so you should know what you should know what's in front of you. And I think this will do. So there are some problems about this that where you want to use this equations that you might want to be familiar with, but the equation itself is pretty straightforward.